theta is going to be b, right? You guys understand that? Cos b. And cos b is going to be adjacent x over hypotenuse. So therefore, these are equivalent.
No, I'm saying like if you ever asked us the question, would we...
Yeah, this is just a unit circle, right? You could just do that, right? Right? So no other questions about that? The reason why is just because, you know, in a triangle there's 180 degrees, 90 takes up half of it, so the other angle is going to be 90 minus theta, right? All right. Write sine A plus B is equal to cos 90 minus A plus B equals cos 90 minus A minus B. Okay, so let's talk about this. Why is this the case? Because we have sine theta is equal to cos 90 minus theta. So sine A plus B, A in this case, we're going to set to theta is equal to A plus B. Okay, so this angle, what was theta, now we're calling it A plus B. Okay, so it's still going to be cos 90 minus, we're subbing in A plus B for theta. So everybody okay up to here?
Yeah.
Okay, so now we're just simplifying this term. So theta, or 90 minus A plus B is just 90 minus A minus B, because we distributed this negative sign. So everybody understand that? Yes?
Say that again.
We just distributed the negative sign into the brackets, so it becomes minus A minus B. That's all that happened here. Okay, yeah.
Or you put the brackets on the pi.
We put the brackets so that we put it back into this formula, this original formula that we developed. So we have cos an angle minus another angle. Does that make sense? That's why we put in the brackets. They don't actually do anything. They just make it clear that this is one angle we're considering and this is the other. Okay? All right, next we use the subtraction formula for cosine to expand and simplify this formula. So we're going to use this formula now, where our two angles are 90 minus A and B. And we're going to use this formula. There is our original that we started with. Here's the one that we just developed that I showed you. And now here's the formula that we knew from the beginning. Okay? So we're going from here now. And we have to get to this simpler one. So we know cos 90 minus A, this is actually just cos A. Sorry, sine 90 minus A is cos A. Okay, and we know that from this triangle here. Okay, what we just proved here, sine theta is equal to cos 90 minus theta. So cos A is equal to that. It works both ways. Okay, so sine theta is equal to cos 90 minus theta, and cos A is equal to sine 90 minus A. It works both ways. You guys want to see the proof the other way? Or you can take my word for it. Okay, I'll show you. Let's do it. Okay, so we're going to prove that this is equal to this. So let's do cos A first. Cos A is equal to y over z, adjacent over hypotenuse, sine pi over 2 minus A is just equal to 90 minus A is B, so that's equal to sine B, right? Everybody understand that? Why that's equal to that? Because this is 90, 90 minus that, you'll be left with sine B. Sine B is equal to opposite y over z. So sine B is equal to, sine 90 minus A is equal to cos A. Okay? All right. So if that's the case, then this all becomes cos A. Using the exact same logic, this all becomes sine A. This goes to there, and this goes to there. And you're left with this nifty formula. Yeah, Gianluca.
The proof that you just showed,
Yeah.
so it says that it's equal to sine b, so why isn't it just sine b squared instead of cos A sine b?
No. Here.
Yeah.
Yeah, it could be. Oh, I know why. Because Gianluca, A and B are not always related in the same triangle. Okay? And I just happened to call this B. This could have been called, I don't know, E. Okay? Because you're looking at this B and making it the same as this B, which would make it sine B squared, right? That's what you were thinking, right? This multiplied by this. But this B could be anything. Doesn't have to be. I just used B to prove it here. I just used the letter B. Okay? But doesn't mean that that B is the same as this B. Okay? So this, this could have been E here. And this would have been E. Okay? That's why. All right. Next one, E. Use a calculator to verify our addition formula. So here's our addition formula that we just developed. Cosine plus sine cos. We get that. If we take those same values, add them, we get that. So we know it works. F. Determine and verify the subtraction formula for sine A minus B using the addition formula you found in D. So when we proved cos, we found the subtraction formula first. When we prove sine, we find the addition formula first. So it's opposite, right? So now we're just looking for the subtraction formula. So here it is, F. Our subtraction formula that we found out, we're going to sub in for B, we're going to sub in negative B. So the process is the same, either for cosine or for sine. The only difference is with sine, we start with the subtraction formula. Well, actually, sine we start with the subtraction formula as well to develop it. This should be, I think this might be a mistake here. This should be plus.
How can you start the subtraction? We're solving for subtraction.
Yeah, sorry. We're starting with the addition formula, which is here. They just put this in early, right? That's the final result. You could leave it there, but we're starting with the addition formula. We're subbing in negative B for B, and then we get this, and then we know because sine is an odd function, sine negative B becomes negative sine B, so that's why this goes to this, the exact same reasons, right? And cos negative B is just cos B, right? Because it's an even function. Okay, so we end up with this formula. Any questions? Next step, we prove it, so we get these two values, which are the same. Almost done. G. We're going to prove the tan formula now. So we know that tan is equal to sine theta over cos theta. We use this identity to determine the addition and subtraction formulas for tan A plus B and tan A minus B. Use a calculator to verify. So here, let's go through G quickly here. Tan A plus B. So it's sine over cos. So there's our angle, A plus B. So we have sine A plus B over cos A plus B. That step's simple. This step is also simple because we have developed these formulas already. So these formulas you're going to have memorized. Sine A plus B is equal to that. Cos A plus B is equal to that. These are memorized. So far 10 is easier. The only tricky part in 10 is you have to remember to multiply not just the denominator, but the denominator and the numerator by 1 over cos A, cos B. So what that means is I'm multiplying this equation by this. Yep. No.
Sir,
Hi.
may I ask your